Welcome back. Problem 14-28. This problem is taken from chapter number 14, Energy Methods, and book name is Mechanics of Material by R.C. Hibbeler. So statement is determine the vertical displacement of joint C. The member of truss are 20, 14, T6 aluminum, 40 millimeter diameter rods. So you can see this is the truss that is composed of 20, 40 T6 aluminum. Diameter of each rod is 40 millimeter, and there is a point load of 30 kilonewton at point C. So this, due to this load, this point C will move downward. So this is the vertical displacement of point C, which we have to find. So you can see the given data, all the diameters are equal, which is D, and that is 0.04 meter. Length of AB and BC, AB and BC are 2 millimeter, BD is 1.5 millimeter, and by using Pythagoras theorem, this will be also this will be 2.5. I think this is 2.5. Yes, this is 2.5. So we will correct it. This is 2.5. I will write it 2.5 meter. So you have to find the displacement C. Let this C will move this distance. So this is del C. Now we know that using conservation of energy, this formula UC is equal to UAI. Now what is UC? So you can see this is 30 kilonewton. So this external force will do work which is equal to UC, and this work is stored in the form of strain energy. So external work done is equal to UC, and that will be equal to 1 over 2 30 kilonewtons. So it will be 30 into 10 raised to power 3 multiply by this delta C. And what about UAI? So we will find UAI, and we know that UAI is equal to sum of n square L divided by 2AE, where N is axial load in this each member. So for every member, we have to write 1 over 2AE. So you can see we have 1, 2, 3, 4, 5 member. So I will write FAD square into length LAD plus FDC square into LDC plus FBD square into LBD plus FAB square into LAB plus FBC square into LBC. So what we are going to do, we are going to find these forces FAD, FCD, FBD, FAB and FBC by using method of joint. So what will be the first step is that we will take this joint C. So we will take joint C and we will draw the free body diagram. Now you can see due to this load, this is joint C. So this member FBC will exert force in this direction, and this member BD will act force in this direction at point C. Clear? So I will draw it. This is point C. This is 30 kilonewton load. 30 kilonewton load. This is FBC, which is in this direction. This 30 FBC, and this load will exert this direction force. This is FCD or FDC. Now you can see this is 2 and the vertical height is 1.5. So if I draw a right angle triangle over here, so this is 2, this is 1.5. So by using Pythagoras theorem, this will be 2.5 meter. Now we'll apply equation of equilibrium. So first equation of equilibrium is that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see minus 30, which is downward, plus this component will have two forces. One is along x-axis and another one is along y-axis. and this component will be equal to FCD sine theta, and this component will be FCD cos theta. And what is theta? So if theta is this one, so theta is cos theta will be equal to 2 divided by 2.5, clear, and sine theta will be equal to 1.5 divided by 2.5. Okay, so the vertical component is plus FCD sine theta is equal to 0. So FCD sine theta is 1.5 divided by 2.5 is equal to 30. So from here this FCD will be equal to 50 kilonewton. Now you can see that this FCD is in this direction. As a result, this force in this member FCD will be in this direction. Clear? And it means that FCD is in tension. So I will write T. Now we'll apply another equation of equilibrium, that sum of all forces along x direction must be equal to 0 and force toward right side is taken as positive. So FBC is in right direction minus FCD cos of theta is in opposite direction. Their sum must be equal to 0. So FBC is equal to FCD cos of theta. So FCD is 50 and cos of theta is 2 divided by 2.5. And when you solve this, you will get this FBC will be equal to 40 kilonewton. Now you can see that this force FBC is in this direction. The member applying force at point C is in this direction. As a result, Newton's third law, this FBC will be in compression. So I will write it here as compression. Now we have this force. We will move toward another joint C, that is joint D. Another joint which is joint D. Let me show you. This is the joint D. You can see the force at this joint will be, this force will be in this direction, because here you can see you have taken this in upward. As a result, this force will exert in this direction. Similarly, FAD will be in this direction and FBD will be in upward direction. You can also assume and you can do the method of joint at this point. So FBD is in upward direction. This is FBD, clear. This one member is this FCD, which is 50. FCD is equal to 50 kilonewtons, clear. And this FAD, which is not known, this is FAD is not known. So again you can see the ratio of their side. You will be having right angle triangle 2, 1.5 and 2. So same is the here 2, 1.5 and 2. So I will draw the same right angle triangle on both sides. So this is 2, 1.5 and 2.5. You will have the same over here 2, 1.5 and 2.5. Now we will have two component of this force, one along y direction and other along x direction. Similarly, it will have two component, one is this and other one is this one. So this component will be equal to FCD into cos of theta. So cos of theta, if theta is this one, so cos of theta is equal to 2 divided by 2.5, and this component will be FCD sine of theta, which is 1.5 divided by 2.5. And same is the case here. This will be FAD cos theta, which is 2 divided by 2.5. And the vertical component is FAD sine theta, which will be 1.5 divided by 2.5. Okay. Now you can apply the equation of equilibrium. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0 and force in this direction is taken as positive. So you can see two forces acting horizontally. One is this one and another one is this one. So FAD into 2 over 2.5 minus FAD plus FCD into 2 over 2.5 is equal to 0. So FAD into 2 divided by 2.5 will be equal to FCD into 2 over 2.5. So these two terms will cancel. So we will get FAD is equal to FCD. FCD. Now what we will do is that we will apply another equation of equilibrium, and again if you further simplify it, you can see FCD is 50. So from here FAD will be also equal to 50 kilonewton. Okay. Now moving toward another equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see FBD is acting upward. So FBD minus the vertical component, these two, these are minus. So FAD is 50. Let me write 50 into 1.5 divided by 2.5 minus 50 into 1.5 divided by 2.5 is equal to 0. And again when you solve for this FBD, so FBD will be equal to 60 kilonewton, and you can see the FBD is acting upward. This force acting upward, this FB force member BD is applied upward force on this D. So as a result, this member FBD will be in compression. So I will write it C. Clear? And FAD was in tension. Why? You can see that FAD is in this direction. So as a result, this force in this member will be in tension. Now we have four forces, 1, 2, 3 and 4. So there are total 1, 2, 3, 4, 5 members. So we have to find one more force. So what we will do is that we will take this joint B. Clear? And we will apply the equation of equilibrium. So you can see this FBD, the force this member BD will apply at point B will be this one. Clear? Similarly, FAB will be this one. FBC will be this one, and there is a roller support which apply force which is BY. Clear? So we will apply equation of equilibrium by using method of joint at point B. So joint B. So at this is joint B. So you having a vertical force of FBD which is 60 kilonewton. You have a vertical reaction force due to roller support, that is BY. FAB is the horizontal force that member AB exert at point B, and FBC which is 40 kilonewton. Now you can apply equation of equilibrium. So only we need FAB. So we will apply equation of equilibrium, that sum of all forces along x direction must be equal to 0 and force toward right is positive. So FAB minus this FBC which is 40 is equal to 0. So it means that FAB is also equal to 40 kilonewton. And you can see that FAB is toward right direction. So by Newton third law, the force in member AB will be in this direction. So AB will be in compression. So I will write FAB is in compression. Now you have all the forces. So what we are going to do is that we will put it in this formula. So let me put it over here. UA due to I is equal to 1 over 2 A. What is A? So area of is for rod is pi by 4 d square. So d is 0.04. So 0.04 square. And what is E? So E for A992. Okay. So I will go to the property tables, and you can say you have this table SI unit. So here you can see that for 2014 T6 this is 73.1 in gigapascal. 73.1 into 10 raised to power 9. Clear? Multiply by FAD. Now where is FAD? So you can see FAD is this one, which you can see FAD is 50 kilonewton. So I will write 50 kilonewton. So 50 into 10 raised to power 3 whole square into length of AD. Length of AD is 2.5. So 2.5 plus FDC. So FDC is also 50, you can say, and FDC is 2.5. So instead of writing it again, so I will just multiply it with 2. Clear? Plus FBD. So FBD is this one, 60 kilonewton. So I will write 60 into 10 raised to power 3 multiplied by length is 1.5. Clear? Plus you can see that FAB and FBC both are same. FAB and FBC both are same. So I will write 2 times 40 kilonewton into length, and the length is DC, 2 meter. So I will multiply it with 2. Okay. Now when you calculate it, you will get strain energy due to axial loading will come out to be, let me calculate it, it will come out to be 132.27 joules. Also note that there is 4 square, so 60 whole square and 40 into square. So let me correct it as well over here. This will be whole square and this will be also whole square multiplied by 2. Okay. Now it is fine. So you will get strain energy due to axial loading will be this one. Again, using conservation of energy, we know that UE is equal to UAI. So UE was this one, 1 over 2, 30 into 10 raised to power 3, 1 over 2, 30 into 10 raised to power 3 multiplied by delta C is equal to 132.27 joules. So delta C will become equal to 2 multiplied by 132.27 divided by 30 into 10 raised to power 3 will give you vertical displacement of point C, and that will be equal to 8.818 into 10 raised to power minus 3 meter, or in millimeter it will be 8.82 millimeter. So this is the vertical displacement of point C due to load 30 kilonewton. So this is 8.82 millimeter. And that was all about this problem 14-28. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also share my videos with your friends and help them in learning as well. Thank you for watching.